Morning. I set some work yesterday on electrolysis, which I received an email saying that I just don't understand, I don't get it, I can't get it into my head. So I fully understand that, because electrolysis is quite a tough little topic. It definitely will come up in your exams because it's a big topic in science. It's one that you either understand or you don't, and I do know it's going to be a tough one to teach yourself from a book. So I'm not going to set you any physics work today, which is what I would be doing. Instead, I'm going to go over the electrolysis stuff and set yesterday's work again, but hopefully a little video clip might make it make a bit more sense. So a little tutorial I'm going to give you, just using the pen and the piece of paper. Hopefully it can actually make a bit more sense to you, and you can crack on. But I say it's a big topic for chemistry. It's definitely going to be in your exam. It is every single year. So let's have a quick refresher on the foundation of chemistry, because, as I've told you before, chemistry is electrons. It's electrons that do everything in chemistry. If you understand what an electron is, the other things make sense, and they are, as we should know, we call them E-, or they are negative charge. Electrons are negative particles, negative charge, and they can move around, they flow around, and they actually go to where things are positive, because opposites always attract. So we call anything that is charged an ion, don't we? If it's a negative charged particle, it's a negative ion. If it's got an absence of electrons, it's called a positive ion, because it's got positive charge. But any charged particle is called an ion, and that three-letter word is the most important word in chemistry. Ions are charged particles, and they are the things that do things. And their charge is all about the electrons. So very quick recap. We've got our friend the periodic table here. Choo-choo train, it looks like. There we go. If you're sitting there in group 1, you make an ion that is positive 1. It loses an electron, it loses negativity, so it becomes positive. These ones here, they lose 2 bits of negativity, so they become plus 2. These ones here become either plus 2 or plus 3, or sometimes plus 4, but you don't need to know too much about those, and if they do ask you a question on them, they'll tell you what they make. And over here, you've got group 0, they don't do anything. Group 7, they pick up 1, so they become minus 1. These ones pick up 2 electrons, so they become minus 2. These ones pick up 3 electrons, so they become minus 3. All you need to know. When they stick together, we've done lots on this, it's called an ionic bond, so you get an ionic substance, which, let's say you can look at something here. Calcium sits there, it's plus 2. Chlorine is there, it makes minus 1, so they'll stick together with a Ca2 plus joins to a Cl minus, but those pluses and minuses have to balance out, so it means you need an extra one of them to make the 2 minuses, which join to that, so they stick together to make CaCl2. 2 of them and one of those. What we can then do is we can separate them using this process called electrolysis, because electrolysis, which is the whole point of this lesson, literally means, it's Greek actually this bit, electric lysis, or electric splitting. That's the Greek word, it means splitting in half with an axe. So electric splitting. So what you do is you've got a substance here, a massive ionic substance, which is stuck together with loads of bonds, very hard things to separate. But if you use electricity, you can pull the particles one way or the other, because the negative particles get pulled to positive charge, the positive particles get pulled to negative charge. But what you need to do, really important, you have to make sure those ions can float around. Have to make sure those particles can float around and move around, and in order to do that they need to be either melted or molten or dissolved. If they're molten or dissolved, they can, guys, thank you. If they're molten or dissolved, the particles can move around, the ions can move around, which means they then can be separated by the electricity. So I'm going to leave that up there. Those points are really important there. So what we do, we get something like, let's use calcium chloride as an example. You get your calcium and you get your chloride particles dissolved, so calcium chloride solution, it's something that's naturally in seawater, quite common, and it floats around. Calcium and chloride make actually a soluble substance, so they dissolve quite readily. You get Ca and Cl, so that's CaCl2, CaCl2, so the amounts of ions are correct. You then stick some electrodes into some water. This is the negative electrodes. So on here, there's lots and lots and lots and lots of negative electrons. And this one is positive, which means it's sucking up electrons. So these electrons here jump across and they keep going around the circuit. You have to have them apart from each other, which then is going to allow particles to move through the water. All that happens now, it's really quite obvious, really, if you think about it, is the positive particles here, the Ca++, opposites attract, they go to the negative. They go there, and they go there. And the Cl minuses, which are negative, they go there to the positive particle, to the positive electrode, sorry, to the positive electrode, where they stick. So what then happens is you have the calcium forming here, and the chloride ions, they dump their electrons and become chlorine atoms. Chlorine atoms stick together and they make good friends with one another, and they become chlorine gas, or Cl2. So last lesson, or yesterday, I set you some work talking about the products of electrolysis, the various electrodes. In this one, you're going to get chlorine gas at the positive electrode because it's the negative particle, and we know it's negative because it's over here. The metal is always positive, metal always goes to the negative, so the metal forms over here, and that's how you can work out which substances are forming at the electrodes. Another simple one, which is a common question in the exam, would be copper oxide. Well, copper sits down here in the transition metals. It's a +2. Again, you don't need to remember that, they'll tell you. Oxygen is up here, and that forms a 2- because it's in group 6. So you have copper, Cu++, and oxygen, minus, floating around in a solution here. So you've got copper, oxide, copper, floating around, nowhere to go. You flick on some electricity, that's the negative. Who goes there? The positive floats there and says, give me one of your electrons. In fact, it says, give me 2 of your electrons. So it soaks up 2 electrons and it turns into these atoms of copper metal. And this electrode gets bigger and bigger and bigger, turns into a bar of copper. These ones here, they float over to the positive electrode and says, I've got to dump my electrons on you. So that dumps 2 electrons, becomes an oxygen atom. That dumps 2 electrons, becomes an oxygen atom. They stick together, and we know that oxygen sticks together to make O2, which is a gas. So it bubbles off. So at this electrode, you get copper metal. At this electrode, you get oxygen gas bubbling off. Simple, really. It only gets a bit more tricky when you're looking at these ones here, the alkali metals, because we know about alkali metals. We've done these early in year 10. These are ones which, if you drop them into water, they react really violently. They catch fire, they whizzed around on top of the water and burst into flames and stuff. And they make an alkali solution. And if you also remember the acids and alkali topic, an alkali solution is a solution containing OH- ions. So what happens here? Let's forget those for a second. We've got an alkali metal, lithium, sodium, potassium. You can make an ionic solution out of those. Let's use potassium here and chlorine. Potassium chloride, that's in sea salt. So you get a +1 K and -1 Cl because it's in group 7. They stick together to make KCl. I'm going to have 2 of those and 2 of those, and they're going to make 2 calcium chloride substances. You then drop this stuff into water where it dissolves, because it's sea salt, and we know sea salt dissolves. So you end up with this solution of calcium chloride, which is floating around, lots of K pluses and lots of Cl minuses, minding their own business, just floating around in the water, quite happy, and they'll stay there for thousands and thousands of years, not doing an awful lot, making your seawater taste nice. But then, if I come along and put these 2 electrodes in there, flick the switch, this becomes negative, this becomes positive. Who goes where? Well, this one's the easy one. You get the chloride ions whiz all over to the positive electrode, where they lose those 2 negative electrons, and they become chlorine atoms. So you get a chlorine atom there, and I'm doing them in green because chlorine's a green gas, actually means green in Greek. And the chlorine atoms join together, and they bubble off and make chlorine gas. And that should be quite an easy one to work out, to see. And chlorine gas is used in disinfectant. And so we get disinfectant actually from seawater, just by putting electricity through it. The more complicated thing happens when you get an alkali metal here, goes to the negative electrode, and it sucks up one of those electrons. So it becomes a potassium atom, not an ion. It's no longer charged, it soaks up that electron, it's now neutral. Thing with these, as we know, these ones react violently with water. So as soon as that atom is formed, it's nice, I'm going to do it sort of like pinky lilac, because that's the colour that potassium kind of goes when you set fire to it. These are all these potassium atoms that have been formed, but as we know, as soon as they hit the water, they burst into flames and they disappear, and they dissolve. So you never, ever, ever get potassium metal forming here, because as soon as it forms, it disappears. What it actually does is it reacts with the water itself. If you try and follow the particle, you get potassium there. Let's say we've got two of them. Two potassium ions become two potassium atoms. They then react, so you've got potassium and potassium react with water, which is H2O. We know that, they stick around like that. Those potassium atoms come along there, and what they do, they kick out, they react with the water itself. They're more reactive than the hydrogen, and that outcompetes with the hydrogen there, and it turns into something called potassium hydroxide, which is the hydroxide solution there. And these hydrogens have got, one of these hydrogens disappears, it's got nowhere to go, so it bubbles off. So what actually happens with an alkali metal is that hydrogen gas bubbles off instead, leaving us down here with a solution of potassium hydroxide. Alkali metals always make a hydroxide, which is used for bleach and soap and oven cleaner, Mr. Muscle, that sort of stuff. Hydrogen gas is used for fuel cells for cars. So, just by sticking electricity through seawater, we end up with disinfectant, chlorine, bleach and soap, the hydroxide, and hydrogen gas for fuel cells. If you can't really follow that one, don't worry so much. If it does appear in your exam paper, it's going to be right at the very, very end. More important, if you can try and predict what happens at each electrode. The negative electrode always gets the positive one. The positive ion is always a metal, so metals always form here. And the non-metals always form at the positive electrode and bubble off as gas. Your job is just to work out what the gas is called. And you can see the gas from, if it's a bromide, it turns to bromine. If it's oxide, it becomes oxygen. And you'll be able to see the metal because that's the positive ion there. I hope that's made some sort of sense to you and made it hopefully it's a bit easier. If you do struggle with it, please do what Chloe did yesterday and just email me, let me know, and hopefully I can do another tutorial as best as I can. I know it's not easy, but do as well as you can, and hopefully see you in the next couple of weeks at school. Okay, take care. Bye.